All right, so welcome all, and this is also being recorded for future interested persons um, to a tutorial on the use and concept of hierarchical event descriptors, including how to use the tools a tool set that's rapidly being constructed to make the use feasible and easy and even, we hope, enjoyable. So the program today will be, I will give what Kay calls a top-down introduction. Kay will give an example of annotating a data set using current evolving and in-place techniques. And then Young Trong will show more about using tools to process EEG data. And Monique will talk about using the head tools to process fMRI data. And finally, Dora Hermes Miller at Mayo will will demonstrate the first of the additional term libraries or score or head schema, HED schema. This is for the score language for clinical EEG terminology that she is adding to the base head dictionary or schema for use by anyone who may want to make use of those specialized terms. And then we'll end with some general discussion. We'll have a bio break after Kay's session. So, events, experience. Why is it, or how is it that we recount our experience largely as a sequence of events? I did this, then this happened, and then I did this, and this happened, and that happened. I think the likely answer is because our brain is by need a novelty detector. It's tuned to react to and to remember each unpredicted and thus unexpected turn of events, particularly those that require a cognitive response, perhaps to organize behavior in response or to reassess the situation in response. So these moments of novelty, perceived or experienced novelty, are sort of the foremost ability of the brain in controlling in optimizing our behavior and our thinking in light of experience and our goals. So one life event I remembered was as a boy attending a major release of the 1940 Disney animated movie Fantasia. It hadn't been shown for a long time. In fact, it was resuscitated from near disintegration for this performance in 1956. And I seem to remember fragments from one of its acts, Night on Bald Mountain, if you've ever seen it. Though this memory may have been shaped by having seen portions of it in intervening decades. So it remains mostly in my mind a single isolated event. However, of course, the movie Fantasia consists of several classical symphony music pieces, built on which are animated stories, or in one case, abstract moving shapes. And afterwards, I thought of the experience of each of these movements as itself an experience, an event, to see the Bald Mountain movement and to see the other movements. Each I could think of and conceptualize and recall as an event at that time. Events within events. Of course, like other movies, each movement consisted of a series of scenes. Um, Dramatic scenes, that is, story element scenes. Each of which was composed as a series of camera shots, or in this case, virtual camera shots, um, lasting usually 3 to 5 seconds. In each shot, there was also beginning and end moments, or event phases, and there also could have been intermediate high points or disjunctive points in which the action or the music or the story reached some sort of peak or turned in some new direction. So each of these, even of these short movie shot or movie clip events in our experience while watching a movie, can be said to have at least 2 reaction generating phases. Its onset, its offset, plus 1 or more internal moments marking changes in the ongoing event in many cases. So for film viewers, the onset of a new shot or scene or movement or a movie typically produces a more or less strong disjunctive challenge to our ongoing brain-maintained expectation of continuity in our experience, and therefore instigates a more or less strong mental and brain response. But our long-term memory of, for instance, viewing a film typically does not focus directly on first moments in the shot, scenes, movements, or the movie itself. Rather, in our memory, we integrate the experience of viewing the film and recall it as an experience of a story unfolding through time. The movie viewing event as a whole, including its many various disjunctive moments, but not featuring them in most cases. Since the disjunctive points of onset of new movements, new scenes, new shots do not in themselves carry forward the story, when viewing the film as a story, we hardly notice or recall the strong disjunctive changes, for instance, in camera viewpoint, that begin each 3 to 5 second shot or clip in a moving picture. For example, in Fantasia, I believe I should be able to click on this and make it animate. It's very interesting that the animation doesn't work here. But as we all know, in movies are composed of scenes. Once I had this experience of sitting in an airplane in the aisle seat, and it was an airline that had a little TV embedded in the back of each seat. And so as I looked up the aisle, I saw everyone watching a different TV show, but I couldn't hear the sound. So all I saw was changes every 3 to 5 seconds, strong disjunctive changes in scene, in camera view, of course. And they seemed to make no sense at all, particularly when I saw them all out of time with each other in different channels. And it occurred to me, it looks like it would be impossible to make sense of such of an experience, because of course it was the sound and the story that and the careful editing of the editor that the viewers of these movies or these television shows were experiencing. They experienced the continuity provided by that, not this visual disjunctiveness of shot changes. Sorry that didn't work. It worked at home last night. So how do we recount our experience verbally? How do we tell a story of what happened? Following is an example in a detective story written by a skilled, successful mystery writer. Here the detective cautiously approaches the scene of a crime. And he says, or writes, I went to the back of the house. I looked around. Some light came, meaning he noticed and probably looked at it. I noticed the back door. So he focused on the back door, and then he looked and he saw that it was slightly ajar. I opened the door and turned on the kitchen lights. There were marks around the lock. That means, again, he inspected the door or the lock. And it showed me that it had been jimmied. That means I imagined, I induced that it had been jimmied, opened up by force. It occurred to me, now this was an internal imagination, that the guy who did the job might still be inside. Meaning, with a ... there, meaning, and it might be dangerous for me. I might encounter him under very adverse circumstances. I turned off the kitchen light. I waited. The house was silent, meaning he listened. He doesn't say he listened, but that means he listened. And what could he hear? From the outside, I could hear the pulsing hum of the arterial boulevard I had just left. This was an LA, Los Angeles murder mystery. Well, reading this fluently, I don't know that I did with so many commentaries, but it's remarkable how much we can imagine ourselves there, how much these very sparse level of details and these action events and perception events that are referred to in these sentences can give us a rich feeling of being in the story. And so that means that as much as if we remembered the story from the distant past in our own life. It's really quite remarkable. So these are a story, it consists of a string of events, some of them in literary fashion here, labeled as actions, and others conveyed to us in the story by their effect on his awareness or his thinking or his feeling. So he talks about seeing the light and rather than looking for the light. So there's perceptual events and there are action events that he strings together to give us a feeling of experiencing the story, being in the presence within this scene. Now, what about events in neuroimaging experiments? A first rule and very early discovery in event-related EEG and then MEG dynamics is that unexpected sensory events produce noticeable and to some extent reproducible perturbations in EEG or MEG signals, and these arise in cortical areas involved in their perception and in the ensuing response preparation, either cognitive or motor. For instance, the delay potentiation of the N1, the unexpected sound or light, the mismatch negativity, the P300, so-called, the N400. I put the around these in parentheses, in quotes, because they're treated as being a single solitary phenomenon, but our research in EEG dynamics shows that it's the source resolved dynamics show that they're a complex of different source activities. However, these well-known response dynamics also depend strongly on previous context, on previous events, and on their significance with regard to whatever task the subject may be intending or attempting to perform. Further, these responses are most replicable and easily studied using isolated, suddenly presented sensory presentations. In other words, maximizing the disjunctive nature of their appearance. And this was very convenient given the long history of the tachistoscope used in psychology reaction time experiments and perceptual threshold experiments since the 1850s, in which sudden onsets could be used to measure reaction time long before there were computers. As sensory presentation offsets rarely prompt subject motor responses or decision making, their associated brain dynamics, although observed, were not really of much interest. The primary interest came to be the onsets of suddenly presented stimuli. At the same time, of course, development of personal and lab computers made it relatively simple to record the time course of experiments in terms of the usually very sparse sequence of sensory presentations and their onset phases. Stimulus onsets became the time markers for focus of analysis. The times of occurrence of these onsets could be easily output on the parallel port of early computers, most often using an integer code to denote the type of sensory or motor response event. So usually events were, type 17, type 137, type 64, etc. This practice from early personal computers and lab computers set the pattern that is still nearly universally in use today. In EEG systems, MEG systems, fMRI systems that control experiment applications. Nearly all such recorded event tables, quote unquote, consist of a column of event onset latencies and respective, typically integer-coded event types. Even in BIDS, which was created in about 2015, using a third column to record event duration, for instance, the presentation duration of a stimulus, is considered to be optional. This poses a severe problem for neuroinformatics, this practice, because when you come to a data set that's been shared and you look at the event table and you see, what does event type 137 mean? And what happened after that? Did that stay on? Was it a brief flash? What is going on? But that's really all that was typically and very, very often still is recorded concerning events that crucially occur in neuroimaging experiments, time series experiments. Now, in more advanced systems, they can be also, these event types can be alphabetic codes, for instance, target. But again, it's problematic. That's lab jargon. What does event type target mean in this lab, in this experiment? How do you find that out? Well, you have to go to the paper that they wrote, hopefully, about this data. You have to read the methods section. You may have to write them, and they may have to look up notes. They may have to look at the original program and so on. That makes it very difficult to analyze data that is being contributed to data archives currently. But it makes it almost infeasible, certainly infeasible and almost impossible to make large-scale analysis of data across studies, which is the new perspective based on the machine learning, the fantastic results of machine learning. To do that, you need to have not only the basic who, what, when, where, how of the recording recorded, but you need to know exactly what occurred during the recording. What did the participant experience, and what did the participant do exactly? So how better to record the nature of events experienced by participants in a neuroimaging experiment? And this is the where the system of hierarchical event descriptors, or HED, or HEAD for short, comes into play. It's an annotation software standards and software ecosystem. And as far as we know, it's the only one of its type, which is remarkable, actually. There's three base concepts underlying HEAD. First of all, that every experiment has a timeline. Usually clock time, start with time 0 being the the start of the recording, and going in hours, minutes, seconds, milliseconds until the end. Although, of course, there could be some offset, in individual time offset in individual cases. The second basic concept is that of an event, which is considered as an event process unfolding through time. A stimuli was presented. Well, it wasn't only turned on, it was also turned off, typically. So event processes are always occupy time. They unfold through time. Event processes then have can have phase markers. They have onset phase. They have an offset phase. And they may have any number of mid-course disjunctive points, inflection points of some sort, that can be noted and may be important for analysis. For instance, here, in this reaching experiment, the authors, we imagine the authors noting a course correction in the movement of their hand toward the touch screen. And it's been noted here as a phase marker in the event process of the reaching movement. Okay, so events are not onset markers. Onset markers is a marker of an event which unfolds through time. So here's our imagined experiment in which this becomes is an example. Here's the timeline of the experiment. Here are the two basic concepts: the event phase markers, which mark a single point in time on the timeline, and attach those to a particular phase of the event process, and the event processes themselves. So, for instance, the subject sees an image to which they should respond by touching at some point on the screen. So the image has an onset phase and an offset phase. At some point, they begin the imperative response, reaching to touch the screen. That also has an onset and offset, and we've noted a course correction using AI video analysis or motion capture technology, whatever. However, this is another event that the subject experiences, that during this period, the reach task condition is in effect. So they're attempting now during this period of time to reach to touch appropriately the screen in response to some images, say. So a condition in effect is also an event process. It's an event that unfolds across time, and it should be noted as one in the analysis for the analysis of the data. Now, the event phase markers can be onset, and here is some head tag, head string, associated with specifying what it is and what is the event process that it is the onset of. Here is the offset of that same event process. These are both phase markers. Here is another type of phase marker. This is an intermediate phase marker that again has a head string annotation, and it has to be associated with this particular reaching movement, not the display image 1 process and not the display image 2 process, but not the task condition process itself, but with the reaching movement event process. Okay, so you see that the well annotating the nature of events and experience in a neuroimaging experiment, even a rather simple type such as we imagine here, is not easy. So the onset of the task condition also can have should have its HED or head string description, as well as its offset. So what is the history of head? It was developed. It was imagined and first proposed by Nima Bigli-Shamla, who was a student in the Schwartz Center and my lab at UCSD. About 1911, first he wrote a first paper on it in not 1911, excuse me, 2011, and 2013 he wrote the first paper. Then it was taken up in a large Army project with Kay Robbins, who I think was largely instrumental in expanding it and extending it to generation 2 of HED. That was documented in papers in 2016. The goal of HED is to enable description of experiment events to an arbitrary level of detail. Not just target, not just event type 137, but to an arbitrary level of detail. Now, for complex experiments, complex stimuli, you could go on forever providing detail. So that becomes important that it's an arbitrary level of detail, because of course you can't ask someone to exhaustively describe the movie the subject is watching. Although that might be for some analysis desirable, it won't happen. So if you give the sole responsibility to the original author. So the goal is to describe experiment events to an arbitrary level of detail. That means all the detail that you want to put in, or that you can put in, or that you have time to put in, or are interested in putting in. We want to use a common human readable and machine readable language and syntax. We don't want to make it only machine readable. We want to build tools to maximally simplify both the annotation process and its use process. And that's really important, because we have to, inevitably the people who know the most about the data are the authors of the data. And we want to make it as easy as possible and as profitable as possible in terms of additional use that's derived from the work of putting in the head annotation. In future, I can imagine that it will become a requirement for archives and even publication, but that's certainly distant at this point. So last year, our small head working group, led by Kay, made a substantial extension of HED to generation 3, and also moved all the code and the code maintenance and development process to open source on GitHub. So it's a full open source community-based project. And finally, we've been able to get funding for it from the U.S. National Institutes of Mental Health. The program manager said, "Oh, a very timely proposal." Well, it was 10 years after I began talking to the agencies in Washington about the need to do this, but he called it timely in June, so that's good. And also very importantly, and more importantly, the BID Central Steering Committee agreed to sanction that HED terms were allowed in BID's data files of all modalities. It was accepted at the top level, and therefore the authorization extends to all the BIDS imaging modalities. It sanctioned. It wasn't made mandatory, but it was officially sanctioned as the only such system that is under development to our knowledge. So what is the strategy of this Generation 3 HED? We decided that rather than extending the base vocabulary forever, English has something like 100,000 words. So rather than making the head vocabulary stretch out and try to standardize a profusion of terms from different fields or subfields, we would specify a common base vocabulary and then accept extensions to that in the form of HED library schema or library dictionaries built by people within a certain research subfield, for instance, language, or spatial navigation, or movie viewing, or body motion, or music. And in fact, the first, Dora will talk about the first such library schema and its integration into HED. The working group is next turning toward building good head tutorials, which are work in progress now, and importantly, a head tools library to efficiently and easily and effectively search through head annotated data collections, as well as increasing the ease of use of tools to help you annotate your data with HED. So, of course, head is separate from BIDS, it's separate from MATLAB, Python, etc. It uses these environments, its software is connected to these, current software is connected to these environment largely. But it stands alone and could be adapted to any other metadata collection system, or translated into, of course, any other programming language. So here's an example that I won't go into. Kay may go into it further. This was a simultaneous EEG-MEG experiment contributed to Open Neuro Archive by Henson and Wakeman, or Wakeman and Henson, in 2015. It was a face perception task. So a trial consisted of a fixation cross followed by a face in one of 3 categories, with different repetition delays between faces, and then the subjects were asked to do basically a meaningless task, a kind of a foil task, to judge whether the face was symmetrical or not. And then there was a circle to show that the trial was finished. And so beautifully collected data from some less than 20 subjects was put online. And there are more complexities, of course, about the task, when the subjects were asked to fixate, when they were asked to inhibit blinking, and so on. But showed in circles here, in ovals here, are the only information about these 2 trials that Henson and Wakeman contributed when they contributed the data. Basically, they said at 23.8 seconds, there was a face. There was an event of type 7, which was called a trigger. It means it's an onset phase of an event. 7 was presented, and then there was the address of the picture file that was actually shown. they didn't include the event of the button press that the subject performed. But if you're going to analyze the data, we saw the button presses in the data, and we had to write them and say, well, what was going on here? Did the subject press any button or something? And so gradually we drew out of them all the details necessary, and we reformatted that data and submitted it again to OpenNeuro with a complete annotation. And this is not to cast aspersions on them, because when we look through all the data, EEG data particularly contributed so far to OpenNeuro, out of some nearly 100 data sets, only very few are careful to include all the events, all the information about the events that were that are experienced by the subjects or produced by the subjects in the experiments. So how can we go beyond that? How can we fill in these annotations, these metadata annotations about events occurring in neuroimaging experiments to make the data fully machine actionable and analysis ready for anyone who may make use of the shared data? So here the explicit task was evaluate the face symmetry. In fact, they were not interested in the results of that at all, because they were quite subjective. They had a covert purpose of studying memory for the faces. The actual tasks of interest to them were implicit, actually. Face novelty detection, a new face. Non-face recognition, some of the faces were scrambled. Face type recognition, was it famous or not? Face identification, face repetition, face memory, and so on. And there were also two explicit tasks given to the subjects. Fixate during the cross-presentation, they were told, and refrain from blinking during each trial, they were told. So the subjects were doing these three tasks. And implicitly, other tasks, they were identifying novel versus, if not consciously, if not explicitly, certainly we would expect their experience to include recognition of new faces versus old and so on. So actually there was a 3x3 design. There were three types of faces, face pictures. And then there were three different delays between repetitions of the same face. But this was also not included at all in the event table, which again only had markers to the onset of the face pictures. Not the cross, not the circle, not the button press. And the fact that almost all of the data contributed so far to OpenNeuro has some of this same level of imprecision that means that there's a large educational effort that's necessary. And investigators need to become aware of what the value of using additional information about the event structure and the design structure of the experiment, what that can mean for additional analysis that can be done, either by them or by others. So to share analysis-ready data, one must report all the relevant events, perceptual, motor, experiment control events, whatever, and annotate them in a machine actionable form. That means it has to have my use of the term needs to strongly overlap with your use of the term. So we need to have a common language and a common definition of that language. So HEAD uses a controlled vocabulary, a schema of terms, and elaborate software infrastructure for annotation of time series or conceivably other data. Here's the top of the schema tree showing the 6 types of events that HEAD allows annotation of. sensory events, agent actions, data feature events, alpha burst, seizure, so on. Experimental control events, starting this condition, ending that condition. Experimental procedure, we stopped here to adjust the electrodes or whatever. Experiment structure, this is the beginning of one task, the end of another task, the beginning of a rest period, and so on. So all those are events that are within the experience of the participant in the experiment, and therefore deserve and must really have documentation in the form of sufficient annotation. So the words used in description of events are called head tags. They're paths in the head schema. For instance, event/sensory event. Full of annotations of an event, or an event marker also, are head strings, not head tags, head strings. These consist of parenthesized groups of comma-separated head tags. So for instance, event, sensory event, comma. Properties, sensory attribute, sensory presentations, auditory presentation, comma, etc. Now, this is really a mouthful, and we should not and cannot ask that annotators learn this entire scheme or even write it down themselves. So in the current head, short form annotation is supported. In other words, the annotator for this auditory presentation, annotating this, the event consisting of some sort of auditory presentation, only needs to enter or identify that it's a sensory event and an auditory presentation. And then all these hierarchical levels above it, above these terms, above these tags, can be filled in automatically by the software. The advantage of that is that it allows you to search across all sensory presentations, or just across auditory presentation, or just across auditory presentation of tones, or just across auditory presentations of tones in a certain frequency range, or only, et cetera, et cetera. So it makes the search much more flexible to have these hierarchies of terms. And again, head is now accepted since 2019, actually, to support event annotation in EveryVid's modality standard. So the new features introduced in Head Generation 3 are the unique node names. In the schema, a term can only appear once. This allows you to just use the end term and the software to fill in the whole tree for you. So you can say circle instead of saying this. This can be filled in. And then search can be done at any level based on this hierarchy. It allows also defining event concepts. This is a way to let you use lab jargon when you're describing your experiment. If you want to say target, that's fine, as long as somewhere you've defined what a target means in this experiment. So it means a yellow square, or it means a picture of an animal, or if you want to use the word target, well, target itself is not very informative, but if you want to use lab jargon terms, which we all fall into for a matter of convenience in discussing the data in the lab, you can use that in the annotation as long as they're formally defined in another place in the annotation as in terms of the head vocabulary. So, for instance, in the Henson-Wakeman experiment, circle only was a period of time and an event process unfolding in time in which only the circle was present. And this was defined in our head annotation as a visual foreground view of a white circle in the center of the screen, and the background was black. So event phase, the onset of the circle presentation, could be then defined, could be quoted as circle only, define the definition circle only, and its onset. So it's also a shorthand way of completing your annotation. And the offset would be circle only offset. So we can use simple annotation or even lab jargon and have the head tools expand the head string when they are needed for data search in particular. So head library schemas are specialized lexicons, and they extend the head vocabulary to avoid the base schema vocabulary become bloated and almost impossible to learn and to search. So Dora will describe the SCORE library for clinical EEG annotations, which is almost ready for release, I believe. A video events library schema is in conceptual development at this point, but will soon be developed. A library schema for language terms used in experiments on neuroimaging experiments on language is under development by Monique, who will speak later. And any group can propose and build a head library schema for any purpose. It will be included in the construction of full head strings describing events and from any annotation that quotes it. So again, our experience the way we recount, we recall, we explain, we conceptualize our experience it's a very complicated picture. There are disjunctive moments in which one circumstance ends and another begins. There are within a flow of a continuous process that we might experience as a single event. There may be disjunctive points in which there's some novelty is introduced, some inflection point in the trajectory of the process. It is inherently a complex